sit on our butts all day and we write code.
And
eat Pringles right there. Tons of Pringles.
Pringles?
Hey, I haven't had Pringles in a long time.
So it's a good idea to write a function that you're going to use several times. Like rotating a wrist, we're going to use that several times, right? Because we're going to want to rotate the wrist several times. But since we've already written this function, we can call it whenever we want. And we can specify the angle inside this parameter, which I can define up here. And it'll rotate however we want it to. So just to see what a prototype of this function would look like, you can call void rotate wrist, and it's going to take angle, right?
An angle, yes.
Yeah, and this is what the prototype will look like. See how we're calling it by itself? It's not returning any value, so we're going to specify its void, and it's going to take one argument, this negative 720, and we want this to be our angle, right? So we write up here our little parameters parentheses place, int angle, and then whenever we go down here and define our function, I didn't talk about prototypes, did I? Whenever we define our function, don't worry about it. Whenever we define our function, we can use that angle and we can do stuff based on it. So the definition for the function would kind of look like, what's Arduino's syntax for servos?
Oh gosh.
I can't remember.
No idea.
That's something we need to know to teach Webster.
That's true. This is about the C programming language mostly. We'll worry about it later. But anyways, inside this definition, you would write the code that would access the servo and tell the servo how many degrees to turn, which technically it couldn't do 720 because it's a servo, but
Actually, some servos, the servos that we get just do that.
the 360 or
Yeah,
7.
right. Flipping 300 degrees.
Okay, almost 360. It's close enough. They gave us the janky ones.
Every
Whatever.
single
Do you have a book? Oh, you still have that book.
It's all in
Yes.
the book, Daniel.
I think, Derek, that to access the servos, you have to create an object, which is bad. I don't want to talk about
What kind of book is that?
There's a section for servos, you dolt. What
Did-
the-
Do you have to create an object?
I don't know yet.
Did you look at my backpack for that?
Is this the book that's in your backpack? No.
Yes.
Crap, you
Servo 1.
Don't worry about servos right now. We'll talk about object-oriented programming later.
Servo, wait, servo 1.
No, don't look at that.
I'm looking
Doesn't
at
make any sense. Don't look at it. Yeah, close the book, Derek. Close it.
I've already
All you
recorded.
need to worry about, we've abstracted away from you, right? This squiggly line represents the code that would access the servo and turn the servo. All you need to worry about is we've defined functions that have specialized tasks. Functions are really just for modularizing your codes. Some people call functions modules. No, they don't. Never mind. That's a collection of functions. Is that all we need to talk about for functions, Derek? That check?
Recursion.
No. Let's
What
talk
is
about preprocessor directives now.
What's recursion, Derek?
What's recursion?
Yeah, isn't that what you said?
It's
You
hell.
should Google it.
It's literally hell. No, don't Google it. No, don't Google it.
Why? What is it?
Did you mean recursion? Did you mean recursion?
Don't click on it. Don't click on the link. Bad.
What is it?
It's an Easter egg on Google. If you Google search recursion, it always says, "Did you mean recursion?"
And if you click on it, it'll say it again.
It just
Over and over and over and over again.
ever.
Okay. Eventually we'll get to the actual Arduino stuff, but I think the last thing I want to talk about concerning just C is the preprocessor directives. Voids. And there's really only 2 of them that you'll actually ever use. Wait, yeah. You only use 2 of them.
You should type in ZergRush, that's even funner.
In fact,
What is that?
It's a
Arduino doesn't
game.
even support the majority of them. only supports the two that you actually use, which is fine, I guess. Anyways, you already know what these are, Derek. It's just a fancy word. Let's say I wrote a file and I put a whole bunch of function definitions in it, right? So what do we want to call this file? Derek.c. This is the name of the file, and we wrote a whole bunch of functions. So void init, and we define it. Void foo, define it. Int, do something. And we define it.
See you, Richard.
So we have this file, right?
Mm-hmm. You actually put it. Do you actually put it into the computer like that? Just.
This
Okay.
I failed to tell you about prototypes. I should have told you about them. We don't necessarily have to define a function when we declare it. Like, remember how I said you could say int x, just put a semicolon and be done with it, and then somewhere later on say x equal to 10. See how we're kind of assigning a value on a different line than we're initializing it?
Mm-hmm.
Well, you can kind of do the same thing with a function. So let's say I come up here and I want to make a function called void Derek, but I'm feeling lazy and I don't want to define it. I could just kind of put a semicolon there, and later on down here I can define it. And then I'll write my code in here. This is okay, it's legal. And it's kind of,
That's semicolon, by the way, just right there next to it.
yeah, that's a semicolon.
Okay, there you go.
That's a J.
No, it's not. It's a semicolon.
Semicolon.
I said semicolon.
Shut up, Derek.
Just up there.
The real reason you can do this is because in traditional C, you have to define your functions above your main loop, because if you don't, let's say I called this Derek function, and I define it down here, and this didn't exist, it's going to throw an error because I haven't defined the function yet. The definition for the function doesn't come till later on, and it parses it line by line. That's the main reason function prototypes exist, but however, they did something with the Arduino language, and it doesn't really matter anymore. I can define this function anywhere, and I can call it in here, and it won't give me an error. But you can still make a function prototype, and that's what this is up here. It's pretty much saying, I'm going to eventually define a function named Derek, and that's what it's going to look like, but I'll do it later.
All right.
So anyways, let's say you're working on a really big software project, and rather than having all of your code in one file, you want to separate it among different files. What you do is you create a Derek.h file, and then a Derek.c file. And inside the H file, I put all my prototypes. And inside my C file, I would write all the definitions for my prototypes. And what I can do is over here, I can use preprocessor directives. I'll say
Import.
include,
That was close.
yeah, Derek.h. These are angle brackets, by the way. And
Oh,
what
which-
this is actually going to do,
How can you tell the difference between angle brackets? Wait. Is it those ones that are, like look like
Alligators.
alligators, it's the greater than and less than signs.
Okay, greater than and less than ones. There you go.
There we go. That's a bit better. What this, I kind of need to explain how the program's compiled. The program actually doesn't go through the compiler first. It goes through something called a preprocessor first. So when you write a code file, this file right here, let's just say it's called main.h. I wrote it, and what was I getting? I just lost my train of thought.
Preprocessor.
Preprocessor? What about them?
I don't know.
Ah.
I'm like learning here, so.
Oh, okay. Oh, yeah, that's right.
You're staggering
the life
off.
of a program. So I made this program, right, and I want to compile it. It actually goes through 3 steps when you compile it. It gets preprocessed by going through a preprocessor. I misspelled it. And then it gets compiled. then it gets linked.
One tangent after another.
You already know what the word compiled means. When a code is compiled, it goes line by line and translated into machine code. That's what compiled means, and it does go from bottom or from top to bottom. However, don't worry about the linked. We're just worried about pre-process right now. This actually happens before the compiling, and what this does is it pretty much runs through your file and it looks for things that start with a number sign like this. Programmers call it the pound. Is that right? Or the bang? No, the bang's the exclamation mark. Yeah, we call this the pound. And it looks for statements that start with the pound, and then what it does is it kind of restructures the way your file looks. So this particular preprocessor, the include one, it's going to restructure the way your file looks by including the Derek.h file. So what it's going to do is going to search through your entire computer and try to find Derek.h. Let's say you stored it in some arbitrary directory. It finds Derek.h. So what it's going to do is it's going to take all the code inside of Derek.h and it's going to stick it right here, right where the include statement used to be. It's the word they use to call that is interpolation. It's interpolating the code inside of the file. And that's what I mean when I say it restructures the file, in that it changes the file prior to it being compiled. So this particular one, the include preprocessor, just sticks code inside of your file. And it's commonly used when you want to have your definitions for functions in a different file, and you don't want to clutter your main program. So this kind of consolidates all of these definitions into one line, include Derek.h. And anywhere inside of this loop, I can call one of these functions. So foo, if I wanted to, or do something, I can call these, and it's perfectly legal because I did define it. It's just you can't really see it because it hasn't been pre-processed yet. Yes, Derek?
Now, is .h just to declare them, and then .c is for the actual
Definitions?
declaration?
Yes.
This
is for,
definitions.
the .c file is for putting the actual definitions. This is just for your prototypes.
Is the definitions just for you, by the way?
The definitions, just for me, yeah.
Okay, yeah. Just
I
notes.
define them. You don't need to worry about
They're
how they
notes,
work.
right? They're just notes, or no?
No, these are not just notes. These are
No,
function prototypes.
Derek.c.
Yeah. Derek.c, I haven't run anything in this file yet.
But it's just notes?
No, what it is it's the actual definitions. So void init, right? And I put the brace, and I would define this function. And then I would define foo, and then I would define something.
What does that say, by the way?
Void. You saw that, didn't you, Derek? Void init.
Sure.
So over here, I'm just saying, hey, I'm eventually going to write a function called init, and then over here, I'm actually writing the function in a different file.
Inifs.
Yeah, so we kind of split up our code into two different files, the .c file and the .h file.
Mm-hmm.
The .h file is purely just for prototypes. So we're going to write a function eventually. The .c, which by convention does have the same name, actually no, it has to have the same name in this case, is where we put our actual definitions for our functions. So we would define each one of these functions.
It's like importing a package in Java?
Yes, it is, just like importing a package. That's what the include statement does. Restructures our program. So technically, I could, this is considered bad programming practice, I can include any kind of file I want to. So let's say I had a file called derek.txt. I can include that. It's just going to find derek.txt, and it's going to copy and paste the code right there.
It's going to search your computer for that type of file that you saved it
Well,
as.
it first looks in the same folder as
Yeah.
the main program.
Now you don't. There's another option, the angle brackets. You could put angle brackets, or you could put quotes, and they do have different effects. If you put it inside quotes, then the first place it looks for it is inside the current directory. If you put it in brackets, then the first place it looks for it is in, well, it's operating system specific. So For GNU Linux, it's user //user /include. For Windows, I don't know. Windows has the most disgusting file structure in the
Oh,
world.
here we go.
It's got all this random. No, I'm not gonna rant about it.
Do
Whatever.
it. Do it.
You can include whatever you want, but you're stupid if you don't use the convention .h. This is conventional, the
You
.h.
could also list out the directory with the quotations, right?
You could, yes, you could. And that's probably the more efficient way to do it. However, the C programming language was designed to be portable, and more often than not, your specific header files are going to be located in different directories based on different computers. So they usually don't specify the actual directory because of that reason, but we're programming a microcontroller, so it doesn't really matter, but just for your information, that is one preprocessor directive. Now the other one is the defined one, and I've been using this one a lot more recently. Define. And what we can do is, this is going to be kind of confusing, but it's kind of like declaring a variable. So let's say I want to define LED, port 7. No semicolon. Preprocessors never, ever end with semicolons. Remember that.
Okay.
Because it's not actually a C statement. It's a preprocessor statement. So what this is going to do is it's going to define a macro. And anytime I put LED inside of my program, when this is pre-processed,
This is by day.
okay, let's just say this. When it goes into the preprocessor, we're defining LED, right? And then it's going to go line by line through your program, and it's going to look for this term, LED. And wherever it sees LED, it's going to erase it, and it's going to replace it with 7, which you defined it with.
All right.
So it kind of works like a variable. However, it's different from a variable because this does not allocate memory. It doesn't allocate memory for it. It simply replaces it. It interpolates it. Interpolation. So
Why
it
would you-
restructures your program. Yes, sir?
Why would you use that?
Why would you use it? You would use it because this cannot change. I cannot say LED++. Because it's not a variable. It's a preprocessor directive. You would use it when you're defining a constant value, a value that's never going to change. So let's say I'm programming an Arduino, and I want to refer to the 3rd or the 7th port on the Arduino. What I can do is I can define, and I want to connect an LED to it. I can define and name it whatever I want by conventions in all caps. I can define this LED, and I can say 7. And then whenever I want to do something with that port, I can put, instead of 7, instead of directly referring to the port, I can put LED. And it's just kind of a better way to keep track of things inside your mind. It's good programming practice, because it makes your code readable. And when Derek's trying to read your code, which was probably written in chicken scratch, he wants some help. So that's why you would use the define statement, preprocessor. And those are the only preprocessors you'll ever need. Technically, I don't have to specify. Well, actually, let me do something else real quick. I can replace with anything I want. It doesn't have to be a number. I can replace it with...
Can we switch to a darker color, by the way? Like brown?
Okay.
Because that one's kind of fading.
A character.
Never mind, that's
No good. Here's black. This will work.
Let's see.
Yes?
Yes. What do you agree?
Whatever.
What's green?
I can make it whatever. All you need to worry about is that it replaces the text. It simply goes through your file and restructures your actual file prior to being compiled. But I don't actually have to give it a value. I can just say define LED. That's perfectly fine.
Mm-hmm.
Now, it's not going to interpolate it, so if I were to write LED here, you'd get an error.
What would it say in that compile error?
No idea. Never been stupid enough to do it. No joke.
Okay.
But we do define things, in particular, well, these preprocessors don't actually exist.
What?
I mean, these two I just told you, they do exist, but the rest of them, they don't exist within the Arduino language. But if you want like some Easter egg knowledge, I could tell you anyways.
So you're telling me this is the
No, these two, the two I just told you about, do exist in the Arduino language.
LED. Define
That could be
LED.
anything.
Hmm?
That can be any. That's a label essentially. You could put servo. You could put servo port.
Yeah,
And it
it's,
works.
it's a variable. I can, well, it's not really a variable, but the name is variable. I can change it to whatever I want. I decide this name. It's just a convention. Name it something friendly, user-friendly.
So you don't have to use a variable.
You don't have to put a number there. You don't have to give it a value to interpolate. But the reason you would define something and not give something to interpolate is when you're using other kind of preprocessors called conditional preprocessors. And they're pretty much the preprocessor version of an if statement. So I can come down here and say, if
Oh boy.
def LED, and down here end if.
At first I thought you said def do us part.
If def LED. And this is pretty much saying, hey, if you at any point inside this file define a macro called LED, then I am going to compile everything within these two statements, the if def and the end if. If not, then I'm going to completely ignore it. And the only reason you would use this is when you want to compile different versions of code depending on your operating system, which you don't have to worry about since we're programming a microcontroller. But I could potentially have a chunk of code that was only for Windows, I could have a chunk of code that's only for Macintoshes, and I could have a chunk of code that's only for GNU Linux, and I could pass my compiler a macro. I could pass it GNU, I could pass it Mac, I could pass it Windows. And based on that macro that I defined, it's going to compile either the Windows code, the Mac code, or the GNU code. Does that make sense?
All right.
It's all about restructuring your code prior to compiling it. It's not something you'll ever use though, so I'm going to stop talking about it. You're probably getting confused.
Yeah, because I don't know what we're using and what we're not using, basically.
The only thing you'll ever use are the define and the include. What's define do?
Basically, it defines what it like looks for it, and it's a variable.
And it replaces it, right?
Right.
Okay. What's include do? Remember these files over here?
Clearly, it does things. It does things. Int. It goes into it's an int file. It's what you're doing it, and then it goes over to what you named it, which is do something, and then you call it byte A, which is how much the file is. This small amount in the variables. That's what you said. That's what I'm seeing. That's what it is, literally.
The include statement looks for the file you specified and it just sticks it right inside your code. It interpolates it.
Picks up the code and moves it over.
Watcha, right there.
Yeah. So as far as the C programming language goes, that's all that you'll ever really need to know or use. Should I talk about arrays?
Can we talk about what we're gonna use?
So what you're mainly going to use are predefined functions that the people who wrote the language defined.
All right.
Which are all detailed in the book.
All right.
Read the whole thing by 20.
I got tested.
Yeah. So we'll talk about the functions you're actually going to use. I just wanted you to understand functions so that when you use them, you don't get confused.
Mm-hmm.
And most of their functions are going to be void. So for example, let's rebuild the structure of our program. This thing's already dying on me. I like the magenta.
That's pink.
Let me see.
Close enough.
He's colorblind.
Shut up, Derek.
Wait, who's colorblind?
Partial.
Are you really colorblind?
Me? No.
What? No.
Void.
Is that really magenta?
What?
Is that really magenta?
No, it's pink. Well, that is. I don't. Whatever.
I consider that purple.
Same thing. Rainbows are Roy G. Biv. And the last one's violet. Why did you say violet?
I like violet.
Cool story, bro.
Want to hear it again?
No. I know the end. Pay attention.
Okay, I'm just calling a bunch of functions that are built into the language